All right, guys, today we're going to talk about naming ionic and covalent compounds. Then also, if I give you the name of the compound, you should be able to give me the formula. So be able to go both ways. So first off, key fact here you got to know is ionic is between a what and a what? We should get a metal and non-metal. So if you pull out your periodic table, if it's from one of these elements over on the left side and then one over on the right side, that's going to be an ionic bond. Now, if it's covalent bond, that's between two non-metals. So it's two of these elements over here on the right side. So that's the key. You got to identify that first because there's different set of rules for ionic compared to covalent. So we're going to start off with ionic compounds here. So we have magnesium and chlorine. So my chemical formula is MgCl2. All right. So the ionic compounds, easiest ones to name. So first we're going to write them the metal name followed by parentheses of a Roman numeral if it has a variety of charge. This is just for transition metals. With the virtual learning, we're not going to get into the Roman numerals, but I just wanted to throw that in there for, so basically you're just going to have to write the name. So we're just going to write magnesium. Alright, so that's the first step. Whatever element it is, find it on the periodic table, write that name. Now the second step is you're going to write the non-metal, which is always going to be the second element, but you're just going to change the ending to IDE. Alright, so if we look at this, instead of magnesium chlorine, we're going to call it magnesium chloride. So what that IDE basically tells us is that these two elements are chemically bonded together, and it's in an ionic bond, just by looking at the name of it. So that would be an example. Again, we could do another example. Let's say if I give you Li2O. So first element, the name is Li, which is lithium. Second element is oxygen, but we have to change the ending to IDE, so it's going to be oxide. Alright, so that's ionic compounds, very easy. Pretty much we're just adding IDE to the end of the second element. Alright, second one, naming covalent bonds. So again, here we have two non-metals. So first, we're going to write the most metallic one first. Let me get my examples up here. All right. Let's say the most metallic, see where I have room here. Let's say if I have C4H8. So that's going to be our chemical formula. So write the most metallic one first. So to determine which one's the most metallic, it's whichever one's the closest to the metals. So it's whichever one's farthest to the left. If they're in the same group, whichever one is farther down is going to go first. So in this case, we have carbon. So I'm going to write carbon. Write the name of the second element, but changing the ending to IDE. So hydrogen, we're going to turn it into hydride. I'm going to give myself a little space here. Didn't quite write it down far enough. I'll move that down just a little bit farther. So example we're doing is C4H8. Add a prefix to show the number of atoms. Alright, so this is our list of prefixes. So you can use this from your notes anytime you have any type of problems here. So you don't necessarily have to memorize it, but they're pretty standard. So if we go in order from 1 to 10, we have mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. So it's kind of like geometry, like a pentagon has 5 sides, a hexagon has 6 sides. Well, that's the number of atoms here. So it should pretty much make sense here. So add prefix to show the number of atoms. So right here I look at carbon, it has a subscript 4. So I'm going to find 4 in my prefix chart, and that's going to be tetra. So I'm going to add the prefix tetra in front. And then I have a prefix 8. 8 is octa, so I got to add the prefix octa in front of hydride. So the name of this covalent bond, C4H8, is tetracarbon octahydride. So you're going to add a prefix to the first element. The only time you do not add a prefix to the first element is if it's 1. So you'll never write mono for the first one. You can have mono for the second element, that's fine. You will always have a prefix for the second element in a covalent bond. Let's try another one. So let's try good old-fashioned H2O. So right here, again, I know I have hydrogen, I have oxygen, so I'm going to change that to oxide. Now I'm going to add the prefixes, right? So I have 2 hydrogen, so dihydrogen, and then I only have 1 oxygen atom because there's no subscript, so we assume it's 1 monoxide. So dihydrogen monoxide, a good old glass of dihydrogen monoxide. All right, so that's naming covalent bonds there. I give you the formula, you give me the name. Now we're going to go the opposite way. So writing formulas for ionic. So if I have the example here. All right, so let's say this is the first example we're going to do, potassium oxide. So write the symbol for the cation ion first. Cation ion's a positive ion. Remember, C, a positive ion. Didn't mean to do that yet. So that's always going to be the metal. So potassium, find it on the periodic table. I know it is K. The second symbol, oxide, I know I'm talking about oxygen, so that's going to be an O. Now determine the charge for each one. All right, again, if you use this is in the answer key section. My periodic table with all the notes, I actually put what charge it forms, what ion it forms. Otherwise, you can always go back to the valence electrons. We know potassium has 1, so it's going to get rid of that 1. So if it gets rid of an electron, it's going to be a positive 1 charge. Oxygen, on the other hand, we know has 6 valence electrons. So it wants to gain 2 more, so that's going to form a negative 2 charge. So how we're going to do this, again, you don't have to draw out the electron dot diagrams. If that helps you, you can, because then you can see, oh, I need another potassium to finish off to make this oxygen happy. So it says add subscripts, so the compound has an overall 0 charge. So if I have a positive 1 and I have a negative 2, well, that's not overall charge of 0 yet. So I actually need 2 atoms of potassium. So basically what works a lot of times is if you just bring these charges, kind of cross them, and that's going to give you your subscripts here. So if I have K2O, I have 2 positive 1 charges, and I have 1 negative 2, so my overall charge is 0. So my chemical formula for this one is just K2O. So when we write the chemical formula, we don't include the charges, but we need to know the charges in order to get the correct number of subscripts there. All right, next one, calcium bromide. So again, you can go back to your steps. You have the steps in your notes there, so use them. We have calcium, we have Ca, bromide is going to be Br. 2, determine the charge for each. Calcium, I know is in group 2, 2 valence electrons, it's going to get rid of them, so it's going to form a positive 2. Bromine, it has 7 valence electrons, so it's going to take in one more, it's going to form a negative 1. So again, I need to make step 3, add subscripts to the compound so it has an overall charge of 0. So I know if I bring this 2 down here, right, I would have positive 2 with 1 calcium atom, and I would have 2 bromine atoms, each with a negative 1. So therefore, my chemical formula is just CaBr2. So calcium bromide is CaBr2. All right, last one. We have magnesium nitride. So magnesium, we get Mg, nitrogen N. Step 2, determine the charge for each one. Magnesium, again group 2, gets rid of those 2, so it's going to have a positive 2. And then nitrogen is a negative 3. It's in group 15, takes in 3 electrons. Alright, so they do not equal each other now. If I just add another magnesium, then I have positive 4, negative 3, still not balanced out. So really we're looking for like the least common multiple between these two. But again, if we bring them down and across, if we have 2 nitrogen and we have 3 magnesiums, positive 2 charge times 3 atoms of magnesium, that kind of gives us a positive 6. If I have 2 atoms of nitrogen, each one has a negative 3 charge, that's going to give us negative 3 charge, or negative 6 charge. So again, they equal out to 0. And so that's how we know we have it correct. So my formula is Mg3N2. So that's writing formulas for ionic compounds. You got to look at the charges in order to get the correct subscripts. All right, writing formulas for covalent. All right, you're going to write the symbol for each element in order, and then you're just going to use the prefixes. So write the symbol for each element in order. So I have hydrogen, H, oxide, I know is O. Now we're going to use the prefixes chart. So I don't have it on the slide, but we know di is 2 and mono is 1, so I don't have to put a 1 there. So dihydrogen monoxide is H2O. Next one, carbon tetrachloride. So again, write the symbols. We have C, tetrachloride, so chlorine is Cl. Make sure you pay attention to capital and lowercase. If an atomic symbol is 2 letters, the first letter is always capital, the second letter is always lowercase. That's very important because when you start writing them next to each other, you got to know whether it's a new element or if it's the second letter of a previous one. So here we go, carbon. It does not have a prefix there, so that must mean it's 1 carbon atom. So we don't have to write the subscript 1. Tetra is 4, so carbon tetrachloride is just CCl4. Last one, trisodium monoxide. So sodium, we have Na. We have oxide again. So looking at the prefixes now, tri, 3, monoxide, we have 1. So I'm just gonna leave it just like that. Na3O. All right, so that's naming compounds and getting the formulas from the compounds' names.